Today we are going to revise gaseous state lesson. That is up to gas laws, up to ideal gas equation. Syllabus clearly I have told you. The syllabus is what? Gaseous state up to ideal gas equation. This week, whatever the syllabus we have, the same syllabus will be there from gaseous state. Okay. After that, chemical bond lesson completely will be there for screening. Please do prepare well. Do not waste time. Okay. And now today we are going to discuss for tomorrow's test revision. Okay, so revision of gas laws first. So the Boyle's law. The Boyle's law is what now here given by the volume is inversely proportional to pressure when temperature is constant and number of moles constant. Here number of moles nothing but mass. Mass is constant means what for the given gas. Number of moles also will be constant. So temperature and number of moles will be constant. What are measurable properties generally? Volume, pressure, temperature, number of moles are the measurable properties of gas. Now, what are kept constant in Boyle's law? Temperature is kept constant and number of moles kept constant. And when temperature is kept constant and draw the graph plotted at temperature, constant temperature are called what? The graphs which are plotted at constant temperature are known as isotherms, isothermal graphs, otherwise isotherms simply. Now, this is about what now? Boyle's law. Next one here. From this equation, V is equal to 1 constant into 1 by P. That means what? P into V is equal to constant we get. P into V is equal to constant. So then we write what? P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2 is what? The equation of Boyle's law. The main equation of Boyle's law is what? P1 V1 initially is equal to P2 V2 finally for the given gas. Okay. That means when you change the pressure of gas and volume of gas, from P1 to P2 and V1 to V2, we have to use formula what? P1 V1 is equal to P2 V2. That point you keep in mind. Next one, density generally mass by volume, we know. Density is equal to mass by volume. When mass is constant, density is equal to 1 by V we can write because mass is constant here. So wherever D is equal to 1 by V we can write, or wherever V is there 1 by D we can write. If we take V is equal to 1 by D we can write, isn't it? So wherever V is there, what we can write? 1 by D. In place of V1, what we can take? 1 by D1. In place of V1, what we can take now? 1 by D1 we can take. In place of V2, what we can write? 1 by D2. 1 by D2. The same way we have taken here. In place of V, what we can write? 1 by D. In place of V, what we have written? 1 by D we wrote. So V is equal to 1 by D here. So 1 by D proportional to 1 by P. That means D is proportional to pressure. Density is proportional to pressure. Then what we can get the formula? P1 by D1 is equal to P2 by D2. P2 by D2. So P1 by D1 is equal to what? P2 by D2. It is what? Another formula for Boyle's law. This is called modified Boyle's law. This equation is for what? Modified Boyle's law. We have taken density in place of volume. Okay, ma. So P1 V1 is equal to P2 V2 at constant temperature and number of moles. And also P1 by D1 is equal to P2 by D2. These two equations are related to what? Boyle's law. That point keep in mind. Next, Charles' law is there. So according to Charles' law, what here? Volume is directly proportional to temperature at constant pressure and number of moles. Number of moles kept constant means mass is kept constant. For the given mass of gas. For the given mass of gas means what? Mass is kept constant. Then number of moles for the given gas will be constant. Because number of moles formula what? Mass by molecular mass. When mass is constant, number of moles of the given gas will be constant. So when pressure and number of moles both are constant, what we have to take here? Volume is directly proportional to temperature. This is what I call the Charles' law. Now from this here, V is equal to some constant into T. Then V by T will be constant. V by T will be constant. So we can write equation what? V1 by T1 is equal to V2 by T2. For the given gas, when we change volume V1 to V2 and T1 to T2, when temperature is changed from T1 to T2 and when volume is changed from V1 to V2, we use formula what? V1 by T1 is equal to V2 by T2. That is the Charles' law equation. Okay, ma. So relation between volume and temperature directly proportional. When we heat any gas, what happens, ma? The volume will be expanding. The volume of the gas expands. That's why it is what now directly proportional. These two. When pressure is constant and number of moles constant. Next again, what we can take now? In place of V1, what we can write? I told you. 1 by d1. Mass is constant in this case also. When mass is constant, d is equal to 1 by v. D is equal to 1 by v. Then v is equal to 1 by d. V is equal to 1 by d. We can write. So in place of v1, what we can write? 1 by d1. In place of v2, what we can write? 1 by d2. So in place of v1, what we have written? In place of v1, 1 by d1. So in place of v1, what we wrote? 1 by d1. So v1 plus what we have written? 1 by d1. Okay. In place of v2, what we can write? In place of v2, 1 by d2. 1 by d2. 1 by d2 is written in the form of, in the place of v2. 1 by d1 is written in the form of v1. So what we got now? 1 by d1 t1 is equal to 1 by d2 t2. That means what? Equation what? d1 t1 is equal to d2 t2. Now second equation is what? d1 t1 is equal to d2 t2. So this equation what we can write here? d1 t1 is equal to d2 t2. It is also Charles-Lie equation, but modified Charles-Lie equation is. Now generally Charles-Lie equation is what? v1 by t1 is equal to v2 by t2. That is main equation. From that we also get what now? d1 t1 is equal to d2 t2. That means what here? Density and temperature. How these two are related here? Density and temperature. When we increase temperature, the gas volume will be increasing now. When volume increases, what happens to density? The density will be decreasing, because density and volume always inversely proportional, right? So when we increase temperature of a gas, the gas will be expanding. That is, volume will be increasing. When volume increases, what happens? The density will decrease. So density and temperature both are inversely proportional to each other. Whenever two quantities are inversely proportional, we have to take d1 into t1 is equal to d2 into t2. These two, temperature and density, are inversely proportional. Here, if the equation is in this form, p1 by d1 is equal to p2 by d2. In this case, p and d, numerator and denominator, these two values are directly proportional. Is it clear, man? The same thing also we can imagine. It is imaginary thing here. So when we apply pressure on the gas, if you apply pressure on the gas, what happens now? When you increase pressure on the gas, what happens? Volume will be decreasing. When volume decreases, automatically density must increase. Density will be increased. So on applying pressure, on increasing pressure on the gas, the volume will be decreasing. Compression will take place. Then what happens? Density must increase. So the density of the gas will be increasing when pressure is increasing. That means what now here? Density and pressure, how they are related now? Directly proportional to each other. Okay. So that way we have to understand here. That is one equation. So it is also one of the equations of what? Charles' law. The same thing we can write like this. d1 t1 is equal to d2 t2. Okay. In some books, sometimes will be given like this. d1 by d2. d1 by d2. d2 will be taken left hand side. d1 by d2 is equal to what? t2 by t1. t2 will be here only, but this t1 will go this side now. It will go to denominator here. t2 by t1. So d1 by d2 is equal to what? t2 by t1. Also same formula now. So to make you confused, sometimes instead of giving like this, d1 t1 is equal to d2 t2, will be given sometimes what? d1 by d2 is equal to t2 by t1. So that's why first we have to rearrange the given equation. We have to rearrange and check it. Okay. Next, another important formula for Charles' law is what? The volume of gas at given temperature, T degrees Celsius. At given T degrees Celsius means centigrade temperature. At the given centigrade temperature, the volume of a gas is equal to the volume of a gas, the volume of the same gas at 0 degrees Celsius here. The volume of the gas at 0 degrees Celsius plus 1 by 273 of V0. 1 by 273 of V0 means V0 by 273. 1 by 273 of V0 meaning what? V0 by 273 volume at what temperature? T degrees Celsius. If it is 1 degree Celsius, V0 by 273 into 1 degree. If it is 10 degrees Celsius, V0 by 273 into 10. That way we have taken. So in this way now here, the volume of a given gas at T degrees Celsius is equal to volume of the same gas at 0 degrees Celsius plus V0 by 273 of T degrees Celsius. Okay, man. So suppose we take here the volume of gas is what now here? The volume of gas is what here? X. The volume of gas is what? X at given temperature. Okay. Now, when we increase the temperature by 1 degree Celsius, just we increased how much temperature? 1 degree Celsius, 30 degrees Celsius to 31 degrees Celsius. Just 1 degree we increased. Now, initially at 30 degrees Celsius, some volume is there. V at 30 degrees Celsius is there. Okay. Now we increase it to what? 1 degree Celsius only. We increase it to 31 degrees Celsius only. Just 1 degree Celsius, we increase it from 30 to 31. When 1 degree Celsius is increased, what happens there? How much will be increased in Kelvin temperature? How many units will be increased? When we increase temperature from 30 degrees Celsius to 31 degrees Celsius, on centigrade temperature, we have increased it by 1 unit. 1 degree Celsius, 1 unit temperature we increased. Then in temperature in Kelvin scale you take, suppose. Temperature in Kelvin scale when you take. So what will be increased in the temperature then? 1 degree only. 1 Kelvin only will increase. When we increase temperature from 30 to 31 degrees Celsius, now 30 is converted into Kelvin, 31 also converted into Kelvin. Then also if you take Kelvin temperature also for 30 degrees Celsius and 31 degrees Celsius, the increase in the temperature will be 1 unit only. So whenever we increase the temperature by 1 unit temperature, if you increase now, what happens? 1 by 273 of the volume will be increased. Now initially how much is there? Initially 0 degrees Celsius is there. Now from this how much increased here? 1 by 273 of V naught increased. 1 by 273 of V naught increased at what temperature? 3 degrees Celsius. Okay, man. So this way we have to understand what now here. This is one of the important equations. From this we get what now this one. Now V naught can be taken common here. V naught is taken common. Then what? 1 plus 1 by 273 of T. 1 by 273 of T means T by 273. So 1 plus T by 273. 1 plus T by 273. What is taken common here? V naught. So this is Vt. Vt is equal to what? Vt is equal to V naught plus T by 273. Is it clear, man? So like this, what we have taken out here, the concept of what here? Charles' law we have to consider. Okay, man. Next, Gay-Lussac's law. Next is what? Gay-Lussac's law. Now Gay-Lussac's law. Gay-Lussac's law, according to this law, what now? Pressure is directly proportional to what now? Temperature. Pressure is directly proportional to temperature. So pressure and temperature, how these two are related? Directly proportional. Okay. When it will be possible? When volume is constant and number of moles constant. When volume and number of moles both are constant, what we have taken now? Pressure and temperature both are what? Directly proportional. Okay, ma'am. So yes. So when constant volume and number of moles taken, okay, the pressure is directly proportional to what now? Temperature. These two are directly proportional to each other. Now here, what we have taken? P1 by T1. P1 by T1 is equal to what? P2 by T2. P1 by T1 is equal to what? P2 by T2 is the equation for what? Gay-Lussac's law. The equation for Gay-Lussac's law is what, ma? P1 by T1 is equal to P2 by T2. Why here? These two are related what? Directly. Pressure and temperature. Numerator value, denominator value. Directly or inversely? Directly proportional. Then we get formula like P1 by T1 is equal to P2 by T2. The same equation we can also write P1 into T2. P1 into T2 is equal to P2 into T1. Cross multiplication. Sometimes to make you confused, that way also they'll give you. P1 into T2 is equal to T1 into P2. Also will be given sometimes. Okay, ma. So it's about what now here? The pressure temperature law. Pressure temperature law or Gay-Lussac's law. This Gay-Lussac's law is also called Charles' law 2. Charles' law 2. Otherwise, Emonton's law. Emonton's law also we can say. So it's about what now here? The what here? Concept of what? Gay-Lussac's law. Okay. So here in this case, Gay-Lussac's law we have taken. Next one. Last law is what now? Avogadro's law. What is the last one? Avogadro's law. So Avogadro's law states what now? Avogadro's law states what? At constant temperature and pressure, both will be constant. At constant temperature and constant pressure, the volume of a given mass of gas, is directly proportional to number of moles. Okay. So if number of moles is more, volume also will be more. If you take 1 mole, 22.4 liters. If you take 2 moles, 44.8 liters. That means when you increase number of moles, volume also will increase. When number of moles 1 mole, what will be number of molecules N, capital N? Number of molecules will be Avogadro number. If you take 2 moles here, if you take 2 moles of gas, it will be 2 into Avogadro number. That means when number of moles increasing, the number of molecules also increasing. Na? Capital N indicates what here? Number of molecules. Small n indicates what? Number of moles. So when number of moles increases and number of molecules increases, what happens there? The volume also will be increasing. So volume and number of moles and also volume and number of molecules, both will be directly proportional under similar conditions of what? Temperature and pressure. So at STP condition, if you take, at STP means what? Temperature is 0 degrees Celsius and pressure is what? 1 bar or 1 atm. So in this way now here, when temperature is constant, pressure is constant for all the gases. So equal moles of equal volumes of all gases, under similar conditions of temperature and pressure will contain what? Equal number of moles. That concept we have to understand here. So it's about what now here? The concept of Avogadro's law. So V is proportional to N. Otherwise, V is directly proportional to number of molecules under similar conditions of temperature and pressure. So here what we have taken now equation V1 by N1. V1 by N1 is equal to V2 by N2. That is what now V and N, how they are rated now? Directly proportional. These two are directly proportional. Numerator value, denominator value. So V1 by N1 is equal to V2 by N2. The same formula how we can also write? V1 into N2 is equal to V2 into N1. Also we can write. To confuse you, they may give it like that also. V1 into N2 is equal to N1 into V2. Also we can write. So here capital N is indicating what now? Number of molecules. Small n is indicating what? Number of moles. So volume is directly proportional to number of moles and the number of molecules. So this point mainly we have to understand here. It is about what now here? Revision of gas laws, the important gas laws. Now what is the next topic, important topic here in the syllabus? Ideal gas equation. What is that? Ideal gas equation. So ideal gas equation is what now? PV is equal to nRT. PV is equal to nRT is ideal gas equation. How many gases? Generally we have two types of gases we can classify. What are they? Ideal gases and real gases. Ideal gases and real gases. So ideal gases obey gas laws. Ideal gases will obey gas laws. But real gases do not obey gas laws. The ideal gas is also called perfect gas. Ideal gas is also called what, ma'am? Perfect gas. And real gas is for non-perfect gas, non-ideal gas. Real gas is non-ideal gas. Okay. So now here ideal gas equation is given by what? Ideal gas equation. PV is equal to nRT. PV is equal to nRT. So here PV is equal to nRT is the formula for what? Ideal gas. Okay. Now in this case, what we take P here? In ATM. Okay. So here ATM we can take. If it is taken in ATM, volume should be taken in what? Liters. In liters. Okay. Liters, or we say what? Decimeter cube. Decimeter cube and liter both will be same. 1 liter, otherwise 1 decimeter cube. Remember. Next, here number of moles. N is what? Number of moles. And R is what? Universal gas constant should be taken what? 0.0821 liter atmosphere into what? Mole inverse, Kelvin inverse. So Kelvin inverse, mole inverse. Per Kelvin per mole. It will be what now? Value of what? Universal gas constant. Isn't it? Next, temperature should be always what now here? Kelvin. Kelvin temperature. What we have taken? Kelvin temperature. So Kelvin temperature is taken. Kelvin temperature means absolute temperature. So temperature should be absolute temperature. The universal gas constant should be 0.0821 liter atmosphere. And V is in volume. Pressure is in ATM. Should be taken. Okay. So now when we use this R value is important to understand. When we use 0.0821 liter atmosphere, if you take pressure in ATM and volume in liters. Volume in liters. In this condition only we take what? R value 0.0821. Suppose if we take pressure in what now here? Pascals. Pascal means what? SI unit. If pressure is taken in pascals. So if pressure is equal to, pressure is in pascals, pressure in pascals taken suppose, and volume in meter cube. Meter cube is what now? MKS unit of MKS unit of what? MKS unit of volume. And MKS unit of pressure is what? Pascals. Okay. So Pascals pressure and meter cube volume when you take, what will be taken R value? 8.314 joules we have taken. Joules, Kelvin inverse, mole inverse. Okay. So in joules we have taken MKS unit of energy what is joules. Okay. So in this way, R value in joules should be taken when we take pressure in MKS units and volume in MKS units. So the Pascal is also what now here? Newton meter inverse 2. That means what? Newton per meter square. Newton per meter square means what? When 1 Newton force acts on 1 meter square. When 1 Newton force acts on 1 meter square area, the pressure exerted will be called 1 Pascal. 1 Pascal is equal to what? 1 Newton per 1 meter square. Pressure means what now? Generally force by area. Force is 1 Newton suppose. Area what? Meter square. The Newton per meter square. Otherwise, Newton into meter inverse 2. So when pressure is taken in Newton per meter square or Pascal and volume is taken in meter cube, R should be equal to what now? 8.314 we take. Okay. So like this, which value of R should be taken is important to understand here in this formula. And from this, one more formula, what we have got? Density formula. Density is equal to what more? Density of gas. Density of gas is equal to pressure into molecular mass by RT. So density of gas is equal to what? Given gas. Pressure into molecular mass by RT. PM by RT. So PM by RT is what now here? Pressure of the gas. Okay, man? So pressure, PM is what? Pressure into molecular mass. R is what? Universal gas constant. T is what? Temperature. D gas. Density of gas. It is one equation here. So from this we can get molecular mass also. Molecular mass is equal to dRT by P. And pressure is equal to dRT by M. That is anything we can get here. Anything we can get when we know what? This one. Okay. So when we take the formula of density is equal to what, ma? PM by RT. This formula is important here. Next, one more thing. Open vessel is there, na? Open vessel concept. In case of open vessel concept, gas in open vessel. A gas in open vessel. So when gas is taken in open vessel, what will be formula used here? N1T1 is equal to N2T2. N1T1 is equal to what, ma? N2T2. So what is the concept here? Open gas. Means open vessel. A gas taken in open vessel. In open vessel, when you take gas and heat it, okay, N1 is initial number of moles, N2 is final number of moles left over. T1 is initial temperature and T2 is final temperature. Now here N2 is what now? N2 gas left over. N2 moles left over. N2 moles left. So these many moles left over is equal to what minus what? Okay, initial number of moles minus gas expelled. Gas expelled. How much gas is expelled? Okay, should be subtracted from N1. Initially N1, imagine 1 mole. Initially N1, imagine 1 mole. Now 3 by 5. 3 by 5 of initial moles expelled out. When we heat it, what happened? 3/5. 3/5 of what here? Initial moles expelled outside from the vessel. Then what we have taken? Initial moles 1 minus expelled how much? 3 by 5. That will be equal to what now? Number of moles left over. So number of moles left over in the vessel, N2 value will be equal to what now? N1 minus gas expelled. Or sometimes gas expelled will be asked. So the gas expelled is equal to what? Gas expelled means what? Escaped. Gas expelled is equal to N1 minus what? N2. N1 minus N2. Sometimes N2 will be given. How much gas will be left over at T2 temperature will be given to you. And they will ask you to find out how much gas expelled. Okay, so gas expelled, we have to get it. Okay, ma? So here, how much gas expelled is equal to N1 minus N2. So this formula, we have to understand it. It is open vessel concept. Okay, so in open vessel concept, what is constant? Pressure is constant. Pressure is constant. Atmospheric pressure will be constant on this gas. 1 atm only will be there. Pressure will be 1 atm only. But temperature, we are increasing from T1 to T2. The number of moles will change from N1 to N2. Okay, so in this way, what we have taken out here, the concept of open vessel. And if I mentioned cylinder in question, if you mention, if you are mentioned with what cylinder in the numerical problem, cylinder means what will be constant? Volume will be constant. cycle tube, car tube, cylinder. In all these cases, they are called what? Constant volume systems. Constant volume systems. Volume will be kept constant there. Okay. So in that case, the cylinder kept in fire, cylinder or the house catches fire, where cylinder is present. In all these cases, what is constant in the cylinder? Volume of the gas will be constant. Okay. Initially, some pressure is there in the cylinder, and at high temperature, some other pressure will be there. Pressure will be increased. So when temperature of cylinder is increased from T1 to T2, the pressure inside it will be increased from P1 to P2. But the volume will remain constant in the cylinder. So when the temperature is very high, when temperature is more than its melting point of cylinder, what happens immediately? The explosion takes place. Cylinder will have some withstanding pressure. Up to some pressure only it can withstand. When you increase beyond that pressure, what happens there? It will explode. The cylinder will explode. So that is what our concept of cylinder. Okay, ma? Bye. Good day.